stuff you must know cold. So this is one of the study guides that you're going to have. I've covered some of this with some of the classes and not with some of them, so I'm just going to start from fresh. Reviewing limits. Limits from the left. So looking from the left side of the graph, so your eyes are going to go that way. The notation for that. The limit of f of x. But instead of just saying as x approaches a, to denote that we're talking about from the left side of the graph, we put a little negative sign. We're coming from the negative side. So if we're coming from the right, it would be the limit as x approaches a from the positive side of f of x. These two limits you should memorize. The limit as x approaches 0 of sine x over x is 1. The limit as x approaches 0 of 1 minus cosine x over x is 0. Definition of continuity. A function is continuous at the point x equals a if and only if, first of all, f of a has to exist. There has to be a point. If you plug in a for x, you have to get a y value. Also, the limit as x approaches that value of f of x also has to exist. Now, to go beyond that, the limit has to be the same as our function value. And just a quick show of a case where that is not true. So let's say I have a graph that has a hole in it. So the limit does exist. I could have a point up here. That would be f of x exists. But to be continuous, those two have to be in the same exact spot. So a lot of times you'll have piecewise functions, and you have to test that those points actually connect. Situations where the limit fails to exist. Well, one of them is unbounded behavior. This means that the graph is going zoom or zoom. In other words, you've got asymptotes. You also have the situation where the behavior differs from left to right. Think of a step function or a piecewise function. The last case is oscillation. Now this is more than just like a sine wave. This is a function that is going up, down, up, down, up, down, up, down very, 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 very quickly. Doesn't happen very often, but there we go. All right. Critical points. Critical points occur when f prime is 0 or undefined. Now, just being a critical point is not enough to know if it's a min or a max. To be a minimum, not only is our derivative 0, but f prime changes from positive, minimum, negative to positive. So I always draw a picture, negative to positive. Negative to positive. Maximum, derivative is 0, and f prime changes from positive to negative. Now, a point of inflection is when the second derivative changes signs. So it could be 0 or undefined and changes signs. Derivatives. Let's make sure we remember our notation for derivatives. You could have f prime, you could have dy dx, or the derivative with respect to x of f of x. They all mean the same thing. Now the official definition is the limit as delta x approaches 0 of f of x plus that change in x minus f of x over the change in x. It's slope, but taking that change in x and making it really, really, really tiny. The alternative form that you might see is the limit as x approaches some value of a of f of x minus f at a over x minus a. Chain rule. This is when you have the derivative of a function with a function inside of it. Well, you take the derivative of the outside times the derivative of the inside. Product rule. The derivative of the first times the second, so I'm going to put a time symbol, plus the derivative of the second times the first. Quotient rule. Derivative of the first times the second minus the derivative of the bottom times the top over the bottom squared. Now there's one more I'm going to add in here. So I'm going to add it over here on the bottom. Inverse functions. And I may edit this for next year. The derivative of an inverse function is 1 over the derivative of the inverse function. A lot of times those are from tables. Okay, derivative rules. Power rule. Exponent comes down, subtract 1 from the exponent. Derivative of sign. Now notice it has a u there, because sometimes you can have a function inside there. So it'd be cosine of u du. Cosine. It's negative sine du. Tangent. Secant squared du. Cotangent. Negative cosecant squared du. Secant. Tangent. Secant. And you get the idea, do you? Cosecant. Negative. Change that to cotangent. Change that to cosecant. Natural log. Easy one. 1 over u du. Oh, my favorite. E to the u times the derivative of that exponent. Now the following 4 I suggest memorizing. You don't want to have to prove them every single time. So, inverse sine is 1 over the square root of 1 minus u squared, and I'll put a du. Cosine is negative 1 over the square root of 1 minus u squared du. Tangent, 1 over 1 plus u squared du. Cotangent, guess what? It's negative 1 over 1 plus u squared du. Now a couple of other ones we might want to just throw in here. I'll do a different color so you can see them better. Sorry about that. What about if you have a base other than e? And I'll just do x here. So what if we have the derivative of b to the x? Well, that's going to be natural log of b times b to the x. What if we have log with another base? Well, it's supposed to be 1 over x, right? So 1 over natural log of the base times 1 over x. Now all these can be created if you remember your change of base formula. Situations where the derivative fails to exist. First one, asymptote. Well, the limit doesn't even exist there. So, duh. Whole. It's not continuous. Oh, it's not continuous there either. The other one is when you have sharp turns. Like when you have an absolute value function, for example. Now to the backside. Oops. I gotta find the backside. There it is. Some of these formulas, or theorems, I want to make sure that we all are familiar with. So the mean value theorem for derivatives. This one actually has a condition that we have to start with. F of x has to be continuous and differentiable. If so, then there exists some x value such that f prime of c equals f of b minus f of a over b minus a. Let me explain what that one means. It means if I have a function, and let's say here's a, and blah, 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 and here's b. There's some other x value that if I figure out the slope between a and b, I can find some point on that graph that has the same exact slope. Makes sense, huh? Try drawing it where it doesn't exist. Bet you can't. Fundamental theorem of calculus. All right, getting into the good stuff. The integral from a to b of f of x dx is equal to the antiderivative at b minus the antiderivative at a. Beautiful. Love it. So easy, so helpful. Second fundamental theorem of calculus. So we take the derivative of an integral that has a function of x there. So you're going to plug in that function times the derivative of that function. Area under the curve using trapezoids. Now, trapezoids, we'll just remember, we're going to be taking base 1 plus base 2 divided by 2 times the height. That's the equation for a trapezoidal. So you're going to take a function value plus the next function value, find the average of those, times your difference in x's. And you'll do that over and over and over. Mean value theorem, aka average value. Easy. Average value, you'd find the integral from a to b of f of x dx. But we're going to take the average across that interval. So one way to write it is over b minus a, because we're going to divide by the difference in our x's. Or you might see it as 1 over b minus a, integral from a to b of f of x dx. You might see it either way. Area between two curves. That's going to be the integral of f of x minus g of x dx. The upper function minus the lower function. Disk method. Okay, so when we made disks, remember we had, hold on, sorry about that. So when you have the disk method, remember you could have your function, and then you're rotating it maybe around the x-axis, and you need to know the radius there. So it's pi r, which would be our f of x, squared dx. Now washer method, you're going to take the outer function minus the inner function. So your outer radius minus your inner radius dx. Now a general volume equation, you're taking the area of whatever the figure is, whether it's a circle or blah blah blah, dx. Motion. Position. Sometimes it'll be P of t, or S of t, or X of t. And it's a position usually moving left and right. Just for sake, I'm going to call it P just for fun. Okay, so the velocity would be change in position with the change time. Well, acceleration then is the derivative of velocity, which would then be the second derivative of position. Speed. Now remember, velocity is your change in position, right? And it could be positive or negative, whether it's moving right or left. Speed is the absolute value of velocity. Displacement. Displacement is going to be the integral of v of t dt. In other words, we'd find the position at the end minus the position at the beginning. Oh, how easy. Now, total distance traveled, we would take the absolute value of velocity. Which means if there's a change in direction, you might have from the position at B minus some position where it changes direction, plus the absolute value of where it changed directions minus the beginning. So you may have to break it apart into little bitty pieces. Now to find a new position, see if we can rearrange one of these. So if the displacement was this, and that's equaling the end minus the beginning. Well, if you knew the beginning and you knew how far you went, you could find your new position. Easy. Average velocity. Now, notice the wording is different there. Average velocity is really just the change in position over the change in time. In other words, P of B minus P of A over B minus A. Now, if it said instantaneous, that's V of T. How do we know if speed is increasing? Well, that means our velocity and our acceleration have the same sign. How would we know if it's decreasing? Well, then velocity and acceleration have opposite signs. How do we know if the particle is moving left? Velocity is less than 0. Moves right when the velocity is greater than 0. Easy peasy. Extreme value theorem. Now, for extreme value theorem, f of x has to be continuous. If it's not, then you don't have an extreme value theorem, and it has to be on a closed interval. If we know those things are true, then the absolute max or min could occur at one of 3 locations. X equals A, or X equals B, or a critical value. Now, what is a critical value again? That's when f prime is 0 or undefined. Intermediate value theorem. Well, again, f of x has to be continuous. Now, on this one, it doesn't have to be a closed interval. It could be an open interval. If it does, there exists some x equals c between our 2 endpoints, such that f of A is less than f of C is less than f of B. In other words, let me draw a picture. If I start at this point and end at this point, I am going to go through every single y value between them. That's all IVT says. Now these next few things are things from Algebra 2, from Precal, that we just need to remember. Point slope form. Y minus y1 equals m times x minus x1. Very important. Also, I might say that if they ever ask for a normal line, that means perpendicular. Log properties. All right, and I'll use natural log since that's used mostly here. If I have the natural log of A plus the natural log of B, I can rewrite that as A times B. Natural log of A minus natural log of B can be rewritten as natural log of A over B. If I have a number out front, that becomes an exponent. And vice versa. It's a good way to get an exponent out too. Natural log of 1. E to what exponent gives me 1? Natural log of e. E to what exponent gives me e? Those are good ones to know. Exponential growth and decay. This is when we had that dy dx equaled some k times our value. Well, it ended up being that we had c, which was the initial value, e to some kt. And there you have it.